Hi, my name is Sual Pozel, and I'm the product manager here at Autodesk, and I'm in charge of Autodesk Simulation Mechanical. In this presentation, I will highlight some of the key improvements we're rolling out with the 2017 version of our simulation software. In this release, we focused our efforts on three key areas: advanced Nastran support, meshing and usability enhancements, and result evaluation. So let's take a quick look at each of these focus areas. As you may be well aware, back in Simulation Mechanical 2015, we introduced the Autodesk Nastran solvers and the Autodesk Nastran editor. This initial functionality covered several analysis types. In the 2016 release, we significantly expanded our Nastran capabilities. The 2016 release supported several new nonlinear material models, nonlinear loads, constraints applied to local coordinate systems, and incremental results for nonlinear analyses performed using the Nastran solvers. In Simulation Mechanical 2017, we focused on improving the support for Nastran solvers by including full control over Nastran's parameters for static stress with nonlinear material models within the analysis parameter dialog. In addition, we improved the contact settings dialogs. The 2017 release includes unique controls for Simulation Mechanical solvers and Nastran solvers. These controls are unified in a single redesigned contact options dialog, and they differ based on your selection of global contact settings versus explicit contact pair settings. Now, let's move on to meshing and usability enhancements. In static stress analyses, plate elements can have varying element definitions on a per part or per surface basis. The 2017 release allows you to make this distinction directly using a new browser entry. In static stress analyses, you can now interactively change the thickness, element normal point, and nodal point inputs. When you're post-processing your simulations, there will be cases where you will want to inquire on all 6 components of a certain result type. The 2017 release allows you to inquire on result types such as reactions, internal loads, applied loads, element loads, and stress tensors in a table format, with built-in statistics for minimums, maximums, and summation values where applicable. The next usability enhancement we worked on is around Centroid Creator. For the 2017 release, we redesigned the Centroid Creator dialogs and added descriptive images of the expected outcome and added the ability to control part, surface, and layer numbers for each set of geometry created. Another improvement we worked on was around nodal mesh refinement. Nodal mesh refinements are now listed in a new browser entry where their parameters can be easily edited, copied, deleted, or grouped. Now, let's start focusing on surface mesh related improvements. Our legacy surface mesher predominantly created matched meshes between parts because the Simulation Mechanical solvers relied on mesh matching for most contact types. However, mesh matching can reduce the success rate when meshing complex assemblies. In the 2017 release, a new option is provided in the 3D mesh settings for assemblies, and it's called Create Matched Mesh Between Parts. This option is enabled by default. However, unchecking this option increases the success rate for meshing assemblies. The Nastran solver, when available, is recommended if an unmatched mesh is created. Note that Simulation Mechanical solvers for linear, thermal, and electrostatic analyses rely on smart bonding if welded or bonded contact is used between parts with an unmatched mesh. In addition, a new surface meshing option called Delaunay plus Advancing Front Technique has been added to the 3D mesh settings dialogs. The legacy surface mesher used the Advancing Front method only. Now, you can use the combined Delaunay and Advancing Front meshers to produce more uniform rectangular surface elements. This mesher has the highest success rate when you do not perform surface splitting during CAD model importing and when the Create Matched Mesh Between Parts is not checked. The stress linearization utility has been redesigned, and it is now located within the output bar. The following enhancements are included in this update: support for all brick and TET elements with or without midside nodes, support for 2D plate and shell elements, support for all linear and nonlinear analysis types that produce stress results, full support for model and display unit systems, control of stress classification line divisions, ability to define the first, the last, and the reference points by coordinates or by graphical selection, updated warnings and error messages, export to comma-separated value, and HTML report, which now contains additional information related to the setup and the results of stress linearization, as well as incremental results that update when running a nonlinear analysis. In addition, the 2017 version can now display contact pressure results for applicable analyses performed using the Nastran solvers. We invite you to check out these features and many more improvements in Autodesk Simulation Mechanical 2017. If you'd like to find out more about this software and how it can help you in your design process, please contact your local Autodesk authorized reseller. Thank you for your time.